Hi, this is Zach Anderson, and in this video, I'll be going over problem number 3 of coding problem set 5. Per usual, let's begin by defining the problem. So for this problem, the graders will use the implementation of the message and plain text classes. Given an encrypted message, if you know the shift used to encode the message, decoding it is trivial. If message is the encrypted message and S is the shift, then apply shift gives you the original plaintext message. Do you see why? Yes. The problem, of course, you don't know the shift, blah, blah, blah. So what we're going to do is fill in the methods of the class ciphertext message according to the specifications. So it's going to consist of these guys here, so the init and the decrypt message. So we're using the parent class constructor to make your code more concise, and then find this helper function useful. We'll ignore punctuation. Okay, cool. So let's head over to the code and see what we did. So we have our class of ciphertext message here. We have our first function of init, which takes in two different attributes of self and of text. So a ciphertext message object has two attributes, which is a string determined by input text and a list determined by the helper function load words. Perfect. So first, we build a constructor. So we initialize the message text attribute with the provided text, and then we load a valid words list using this line right here. So that's all we need to do for this original function, or for this first function, pardon me. And then we're good to move on to the second function of decrypt message. So this function is going to decrypt self.message text by trying every possible shift value and finding the quote-unquote best one. The best one will be defined by the shift that creates the maximum number of real words when we apply the apply shift onto the message text. So if S is the original shift value used to encrypt, then we would expect 26 to be the best shift value. Yeah, okay. If multiple shifts are equally good such that they all create the maximum number of words, you may choose any of those shifts. Cool. And then we need to return a tuple of the best shift value used to decrypt the message and the decrypted message text using that shift value. Perfect. So we need to do some variable work first. So we create this variable to store the best decrypted message, and then we need a variable to track the highest number of valid words. So we do that by equaling max words to 0. And then this variable of shift value is going to store the best shift value after all is said and done. So first we need to loop through all of the possible shifts. So we use a for loop to iterate through all of those, and we make sure the range is 26 as it's been defined multiple times above. So we need to apply the current shift and then separate the words and then keep a count of the valid words in the current decryption, because as we said a few moments ago, that is going to help us define what the best shift value is. So this for loop is going to count all the valid words in the decrypted message, and it's going to check the validity of each word, and if it's valid, it's going to add to that count variable. This if statement down here is going to update the best shift in message if the current shift has more valid words. So it just keeps a running best shift based on whatever's running. And finally, after that is all said and done and those have all been identified, we simply use a return statement down here to return the best shift and the decrypted message. So if we come down here and run it, we can see that the expected output of 24 and hello, and then we get an actual output of 24 and hello as well. So it is identical and is working correctly. Thank you for watching.